In section 10.3, we're going to talk about ellipses. They're a little bit different from circles because ellipses are like ovals. Now, similarities to circles are that it's going to have a center, and then the points that are away from the center around the ellipse, that are above, below, to the left, and to the right, they're not going to be the same as a circle because in a circle, all radii of a circle are congruent. For an ellipse, we're going to have these 4 points, and we're going to call them vertices. So first of all, an ellipse is the set of all points in a plane, the sum of whose distances from 2 fixed points called the foci are constant. We're not going to worry about that for right now. For right now, if you know where the center of the ellipse is, there are going to be these 2 points away from the center called vertices. So there's a vertex to the left and right. They're equidistant. And there's a vertex above and below, also equidistant. The equation of an ellipse, a little bit different from a circle. The equation of an ellipse, this one's centered at the origin, but if it's centered somewhere else, it'll look similar to the circle equation. X squared over a squared plus y squared over b squared equals 1. If you take the square root of a squared, a is the distance along this longer axis. So if you kind of draw a line vertical through the center and horizontal through the center, one of them is longer than the other. The longer one is called the major axis, and the major axis is going to be 2a units long. The shorter one is going to be 2b, where b is gotten by taking the square root of b squared. There are 2 different ways of elongating an ellipse. Notice that the first picture is kind of elongated horizontally, where the horizontal axis is the longer one. And the second picture is elongated vertically, where the vertical axis is the longer one. The bigger number, if it's under x, is going to be on the x-axis. If the bigger number is under y, it's going to be on the y-axis, unless we move the ellipse somewhere else. So we're going to talk about the equations. You'll kind of see it down here a little bit, but we'll talk about the equation of an ellipse in a second. There are 2 points that lie on the major axis, and they're called foci. They're each going to be c units away from the center. So if the major axis is the horizontal one, they lie in that horizontal line. And if the major axis is the vertical axis through the ellipse, the foci will be on that. We will give you this set of definitions on a test, but the 2 different types of elongated ellipses, one of them is x minus h squared over a squared plus y minus k squared over b squared equals 1, where the center is at hk, just like with a circle. If the bigger number is under the parentheses with the x, then the ellipse is going to be elongated horizontally. That means the horizontal axis through the center will be the longer one, and the vertical one will be the shorter one. If the horizontal axis is the longer one, the foci will lie on the horizontal axis. To find the location of the foci, you have to find this distance c. We're going to use this equation c squared is equal to a squared minus b squared in order to figure out where the foci lie. Please be cautious. This is not the Pythagorean theorem. It looks awfully similar to it, but it is not. A lot of times we can just look at our picture to determine where all the vertices are at, but the vertices on the ends of the major axis, what you can do is you can add and subtract a from from h to get the major axis vertices. And you can add and subtract b from k to find the axes on the minor axis, the vertices on the minor axis. But what if this is the ellipse. It's elongated vertically. That means that the vertical axis is the longer one. This is the equation. Fair warning, the equation could be written with x first. Well, how are you going to know if it's horizontal or vertical? It's pretty easy. Whichever variable has the bigger number underneath is going to tell you if the major axis is vertical or horizontal. If the bigger number is under x, it'll be elongated horizontally. If the bigger number is under y, it'll be elongated vertically. It's just that if it's elongated vertically, the foci instead lie on the major axis, which is the vertical one. So you can find the foci by using this equation to find c. The center is still at hk. One of the things I want you to notice that h is always in the parentheses with x. K is always in the parentheses with y. And then the major and minor vertices, again, you can probably just figure it out if you graph it on a coordinate plane. But the major vertices are going to be what you get when you add and subtract a from k. And the minor axis vertices are going to be what you get when you add and subtract b from h. None of these formulas mean anything until we actually see them in action. So let's try some examples. In example 1, let's write an equation for the ellipse shown and find the coordinates of the foci. So the first thing is we want to figure out where the center is. Well, let's try to figure out where the axes are. See, there's an axis here, and then it looks like the other one is here. So let's figure out where the center is at. The center appears to be at 1, -3. So that's our h and k. The next thing I want to figure out is how far away the vertices are from the center. So I'm basically going to count tick marks. So let's see, 1, 2, 3, 4, 5, 6, 7, 8. So this is 8 units long. And then 1, 2, 3, 4, 5, 6. This is 6 units long. That means that the longer axis is the horizontal one. That means I'm going to write this equation, x minus h squared over a squared plus y minus k squared over b squared equals 1. I'm going to start erasing stuff because I know what h is. H is 1. And I know what k is. It's -3. But when I plug -3 in here, that's going to become +3. The bigger number is always a. And a squared is 64. And the smaller number is always b. So if b is 6, then b squared is 36. So this is the equation. We also want to find the foci. The foci always lie on the major axis. And this is the major axis. So in order to determine their location, we're going to use that c squared is equal to a squared minus b squared to find c. So c squared is going to be 64 minus 36, which is square root or 28, so c is the square root of 28. And if I go back to the definition here for a second, the foci are at h plus or minus c comma k. So the foci must be at 1 plus or minus the square root of 28, comma, -3. That doesn't look like a comma. I'm going to move that up a little. There we go. I don't have to graph them. It just said find them. And there they are. In number 2, we're going to graph this ellipse, and we're going to find the important information about it. So x plus 3 squared over 100 plus y minus 4 squared over 64 is equal to 1. First thing I got to figure out is where the center is. Remember I said to set these equal to 0 and then solve for x. and that'll tell you the x-coordinate of the center. Set this parentheses equal to 0, and solve for y, and that'll tell you the y-coordinate of the center. So the center is at -3, 4. And the first thing I'm going to do is I'm going to graph -3, 4. The bigger number is under x. That means this is going to be elongated horizontally. So a is 10, because you got to take the square root of 100. So I'm going to put a dot 10 units to the right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I'm going to put a dot 10 units to the left. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So wherever that is over here. B is going to be 8 because it's the square root of 64. So I'm going to put a tick or a vertex 8 units above the center. 1, 2, 3, 4, 5, 6, 7, 8. And 1, 2, 3, 4, 5, 6, 7, 8. And here's the picture of my ellipse. Again, as you can tell, my drawing of ellipses is just as excellent as my drawing of circles. Now, where are the vertices? The nice thing about this is I can just kind of count the tick marks. You don't have to. The major vertices, if you go back and look at the definitions for an ellipse elongated horizontally, are going to be at h plus or minus a comma k. So it's going to be at -3 plus or minus 10 comma k, which means that it's going to be at, it's not k, it's 4. So it's going to be at 7, 4 and at -13, 4. The vertices on the minor axis are going to be at h comma k plus or minus b, which means it's going to be at -3 comma 4 plus or minus 8. So it should be at -3, 12 and at -3, -4. So if you look at this, you can pretty much tell that's where it's at. So we found the center, we found the vertices, we graphed it, and the only other thing we have to do is find the foci. The foci are going to be at h plus or minus c comma k. Again, all I'm doing is I'm going to go back and look at the definitions and figure out which ones to use. So c squared is equal to a squared minus b squared. So it must be 100 minus 64, which is 36. So c must be 6. So the foci must be at -3 plus or minus 6 comma 4, which means the foci are at 3, 4 and -9, 4. Sometimes our ellipse, like our circles, come in expanded form, the one where it's all multiplied out. And in order to write it in a format that is going to be of use to us, we're going to have to use completing the square. But completing the square for this particular equation is going to be just slightly different than it was when we did this for circles. You're going to start the same way. You're going to put the x's together, put a blank. You're going to put the y's together, put a blank. Oops. You're going to subtract 49 from the other side, and since we're adding 2 numbers to the left, we're going to add 2 numbers to the right. The difference is you can only complete the square if the leading coefficient of the trinomial is 1. So whatever number is in front of x squared, you're going to factor out. And when I factor it out, I'm going to be left with x squared minus 2x plus blank. In the second parentheses, there's a 9 in front of the y squared. We're going to factor it out first. And I'm going to be left with y squared minus 6y plus blank. Remember, factor means divide, so I divided both of those terms by 4 here, and I divided both of these by 9. Now I'm going to go complete the square. You fill in the blank by dividing the middle term by 2 and squaring it. -2 divided by 2 is -1. -1 squared is 1. In the second trinomial, negative 6 divided by 2 is negative 3. Negative 3 squared is 9. But notice I didn't go write the numbers on the right-hand side. That's because since we factored out a number, we also factored it out of the blank. We just didn't know what goes in the blank yet. So what you're going to do for the right-hand side is you're going to multiply these together and write that number on the other side. You're going to multiply these together and write that number on the other side. Now, I'm going to rewrite this in factored form. It's going to be x minus 1 squared plus 9y minus 3 squared is equal to 36. And our equations of ellipses are always equal to 1. In order to make the equation equal to 1, we're going to divide everything by 36. What's going to happen is these fractions are going to get reduced. 4 over 36 reduces to 1 over 9. 9 over 36 reduces to 1 over 4. And now I have the equation of my ellipse. All right, now we have to go find all the special information, which are the center, the foci, and the vertices. The center is going to be at 1, 3. Since the bigger number is under x, this is elongated horizontally, and so I go and I use that set of definitions in order to find the vertices and the foci. The vertices along the major axis are h plus or minus a comma k. So it's going to be 1 plus or minus 3 comma 4. Because a squared is 9, so a is 3. The minor vertices are going to be h comma k plus or minus b. Since b squared is 4, b is 2, so it's going to be 1 comma 4 plus or minus 2. You can figure out what the two equations or the two order pairs are going to be. The first one's going to be 4, 4, and the second one's going to be negative 2, 4 for the major axis. For the minor axis, they're going to be 1, 6, and 1, 2. The foci are going to be at h plus or minus c comma k, so I have to figure out what c is. C squared is a squared minus b squared, which is going to be 9 minus 4, or 5, so c is the square root of 5. So the foci is going to be at 1 plus or minus the square root of 5, comma 3. And you just pretty much leave the answer like that because you can. Or you can write it as 1 plus the square root of 5, comma 3, and 1 minus the square root of 5, comma 3, but don't change it into a decimal. In problem 4, write an equation of an ellipse whose foci are at 3, 5, and 1, 5, and a is 4. One of the things that always helps me is if I can draw a picture, because it helps me figure out how the ellipse is elongated. So if the foci are at 3, 5, and 1, 5, the foci always have to be on the major axis. If they're left and right from each other, the major axis is going to be horizontal, so the ellipse must be elongated horizontally. First of all, the foci are also equidistant from the center. If the foci are equidistant from the center, how can I find the center? I could use the midpoint formula. So I add the x's, divide by 2. I add the y's, divide by 2. So I'm going to get 2, comma 5. That's my h and k. Next, how far away from the center are the foci? That's c. Well, if the foci are at 1, 5, and 3, 5, they are 1 unit away from the center, which means c is 1. Because now I know that c squared is equal to a squared minus b squared. I know what a is, so a squared must be 4. I just don't know what b squared is. Let's find it. So c squared is 1. A squared is 4. So negative 3 is equal to negative b squared. So b squared is equal to 3. I don't have to take the square root of it because I don't want to know what b is. I want to know what b squared is. So the equation of the ellipse is x minus h squared over a squared plus y minus k squared over b squared equals 1. So the equation is x minus 2 squared over 4 plus y minus 5 squared over 3 equals 1. Last problem, write the equation of an ellipse that has a vertical major axis of 20 units. Its center is at 3, 0, and c is equal to 7. All right, so I know that my equation is going to be, it's still going to be x minus h squared and y minus k squared. It's just that if it's a vertical major axis, the bigger number is going to be under y. So if the major axis is 20 units long, that's going to be 2a. So a is 10. So I know what a squared is, it's 100. I know what h and k are. The only thing I don't know yet is b squared. But I know c. And I know c squared is equal to a squared minus b squared. So 49 must equal 100 minus b squared. So negative 51 is negative b squared, so b squared must be 51. So the equation is going to be x minus h squared over b squared plus y minus k squared over a squared equals 1. And that's section 10.3 on ellipses.